Assalamualaikum. My name is Adam bin Ismail. My number is 2012 92184. Okay, today I will present about solar tracking system. Okay, first is a introduction. Okay, solar panels are a type of active solar energy, a concept that explains how solar panels use the energy of the sun. Sunlight is collected and effectively converted into electricity by solar panels. Solar cells or photovoltaic cells are organized on the surface of the solar panel in a grid light pattern. Typically, solar panels are made of crystalline silicon, which is used in other industries such as the microprocessor industry, and more expensive gallium arsenide, which is manufactured exclusively for photovoltaic solar cell use. Objective: the main objective of this project is to track the sun and rotate the solar panel accordingly to receive sunlight to the fullest extent, always during the daytime. This movement is achieved by interfacing a stepper motor to the solar panel that changes its direction according to the positioning of the sun. This is achieved using time reference that controls the movement time for 12 hours by a program written in such a way that for every given time the solar panel faces to the sun to generate maximum power, which is stored in batteries and future use. Okay, for the problem statement. First is a solar panel that is used only in fixed installation. Because of this problem, the power that can be generated is low. The other problem is the price for the solar tracking system is very expensive for the family that use more power than usual because it's need to install more than one solar panel to produce enough power. So the second one is the other problem is the related with the solar energy. The fixed solar panels do not aim directly to the sun due to the constant motion of Earth. As the result, the power produced by this device is not the maximum it should produce. The better solution for this system to get the maximum output power is the solar tracking system. This is the main reason the project solar tracker is made. And the third one is to implement a system that is capable of improving a solar power production by 30 to 40%. A microcontroller is used to implement the control circuit, which in turn position a motor used to orient the solar panel optimally. Material. There are 8 material that we use in this project. First is a resistor. Second is a light dependent sensor. Third is a potentiometer. Fourth is a operational amplifier. Fifth is a NPN transistor. 6 is PNP transistor. 7 is a direct current motor, and lastly is a battery 9 volt. For the method, this figure shows that how this solar tracking system work with operational amplifier. In this circuit, there are two 10k resistor. First this one, and second is this one. Two LDR sensor, that is this one, and for this one, or photoresistor that we call it, there is two name. First LDR sensor and second is photoresistor. Third is a potentiometer. Two operational amplifier, two transistor NPN, two PNP transistor, and DC motor. Next we go to the result. Okay, for this one, as you can see, when I start a simulation, I did not use two LDR sensor yet. So you can see these two multimeter for the non-inverting amplifier and inverting amplifier. So as you can see, this value is less than for the inverting amplifier. But as we can see, we just go to the right. This multimeter for non-inverting amplifier will be increased and more than inverting amplifier. As you can see, for the output result for the OM1, it go to the 0 and go through 6.37. So we move to the LDR sensor for the second. So as you can see, this is a value before I go through this LDR sensor. It is 496 millivolt. So when I go to the right, the value will increase to 8.56, and it seems to the output too, or output for OM2. As you can see, it first is go to the 0 volt, then when I go to the right, it goes to the 6.37 volt. And I forgot to mention, when we got no start for the 2 LDR sensor, the motor will not move. So when I go to the right for the LDR sensor 1, it go to the clockwise. But when I go to the LDR 2, it will go to anti-clockwise. What will happen if I go right for the both LDR sensor? The LDR sensor will go stop. Same with the if we go off, the DC motor will be stopped too. So as we go to the result back, we just go through all this figure. Okay, this figure indicates that the photoresistor has reciprocal relationship to luminosity, so the resistance would decline as the strength of light rises. So as the light strength rises, the photoresistor resistance will decrease, which implies that further voltage will reach the op-amp non-inverting terminal. Figure number 2. This figure indicates that the voltmeter has been located to calculate the voltage at the inverting terminal at the pin number 2 and at the non-inverting terminal at the pin number 3. Reference voltage is the inverting terminal, which relies on the frequency of the potentiometer. The voltage at the inverting terminal of the op-amp also changes as the potential value is changed. This figure indicates that the resistance of the photoresistor will reduce as the light intensity rise. So the voltage rise, the voltage is fed into the op-amp's non-inverting terminal, which means that when it go to the rise, when the resistor go to the rise, so the value of the non-inverting terminal will increase and is more than the multimeter for the inverting terminal. Okay, next is this figure indicates that an extra multimeter was mounted to see how much voltage the op-amp output terminal has. The non-inverting terminal will give a value of 8.56 volt, while the light strength is adjusted to the peak, and the inverting terminal will give a value of 5.35 volt. So the value is higher at the non-inverting terminal relative to the inverting terminal. So the value at the output terminal is 6.37. So the clockwise path of the DC motor is going. Okay, next figure is this figure indicates that the light strength has been adjusted to the limit on all sides, which implies that it is because the sun in the center of the panel. At noon, because the panel cannot change, so it receives the maximum light intensity. Therefore, the engine should not turn either. If the light intensity on the left side is set to the utmost, the DC motor move clockwise, whereby the DC motor move counterclockwise if the light intensity is set to the fullest on the right side. When the power of oil light is set to 0, which implies that it occurs throughout the night, the engine will not turn. Basically, at pin number 2 and pin number 3 of op-amp, the voltage comparator takes the voltage measure to which one is the maximum, and it will be shown at the op-amp output. The output voltage is 8.99 volt and is fed to the base of the 2 transistor 2 NPN and PNP transistor, so it will allow the current to flow to the DC motor load. This figure indicates that another multimeter, which is this one, has been installed on the circuit. The voltage at the inverting terminal 5.12 volt is higher relative to the non-inverting terminal, but the voltage output terminal is 0. And this figure indicates that the voltage at the non-inverting terminal 8.56 is higher relative to the reversing terminal, As the light strength on the right side has been raised to 5.35 volt, it will then have a higher performance potential 6.37 volt, and this output will be fed to the base of the two transistor top 2 NPN and PNP transistor to enable the current flow to the DC motor. The DC motor can, however, shift counterclockwise. Okay, for the discussion, okay, as the angle of the sun varies, the degree of light on LDR and the input voltage for the window comparator is no longer half the supply voltage. So the comparator output produce information for the engine that rotates the sun tracking panels. OM1 and OM2 are adjusted such that when the LDRs get the same value of solar light, the motor stays still in point A as less light enter LDR1 and LDR2. The voltage rises to more than half the voltage of the power supply. As a consequence, transistor conducting high and T1 and T4, which means is transistor 1 and transistor 4, are the performance of A1. In this case, the engine begins. If the angle of solar lights varies again and the voltage in point A to less than the voltage of the power supply, the transistor output of A2 are high, and the transistor of T3 and T2, which is transistor 3 and transistor 2, conduct. As a consequence, the motor rotates in the same direction. So in this one, when LDR1 is bright and LDR2 is dim, which means is dark, DC motor will move direction of clockwise, and when LDR1 is dim and LDR2 is bright, DC motor will move direction of anti-clockwise. But when both LDR is bright, DC motor will not move at all. Same with when both LDR is dim, DC motor will not move too. So in conclusion, with global warming continuously impacting the environment in various forms, it is crucial that we begin to take care of nature in any form we can. Technical today emphasize staying sterile and green. Solar power generators and panels are relatively simple, secure, and comfortable to build since they are environmentally friendly. The improvement of solar power devices with intelligent trackers is also the perfect approach for the usage of usable solar resource, and for this advantage, other people combine a solar cell because of the higher price. Nevertheless, as it attach a solar cell, the job would be the same since all criteria have been accomplished. The purpose of this paper was to drive the motor across the signal from the light sensing circuit when the optimal light intensity was reached successfully. The solar tracker may also be improved in potential work by incorporating specific characteristics in terms of safety from rain and wind. Okay, that's it from me. Thank you.